Hi students, welcome to today's lecture on Python programming. So today we will be starting the second unit. Second unit consists of some topics which are already discussed in the first unit itself. So we discussed about the repetition structures such as for loop and while loop in first unit also. So the same topics continue in second unit, and we will try to focus more on these two types of loops again, and we'll focus on examples also. So today we'll be discussing about the for loop and how this for loop can be used for definite iteration. Okay, so let us start our topic today. So what does this definite iteration means? We know that control statements are used for performing repeated actions in Python programs, which are also called as loops, right? And each repeated action done through the loops are called as one iteration of the loop or one pass of the loop. Okay, and we already know that there are two types of loops available in Python. One is uh, repeat an action for a predefined number of times, which is also called as definite iteration. And the other category is perform the action until the program identifies that it needs to stop, which is also called as indefinite iteration. So uh, definite iteration and indefinite iteration, where predefined number of times is what it defines the first category, and infinite iterations is the second category, indefinite iteration. And we will stop based on some criteria in this indefinite iteration. So we already saw some examples for both these categories. Okay, we'll focus more about this and how the definite iteration can be done using the for loop. Okay, so if you look at the simple syntax of a for loop, it looks like this: for some variable in range of some integer expression here, followed by a block of statements. This one is called as uh, the loop header. Okay, this is the loop header, which ends with a colon, and these statements forms the block, the for block, which gets repeated. So these set of statements are repeated until this variable finds some value in this integer expression. So as long as the variable identifies a value in this integer expression, this block of statements gets executed. Okay, once all the values are completed, the loop terminates, right? So we call this as body. This is called as loop body. Okay, so loop header specifies how many number of times the body has to be executed, right? And the body statements, that is statement 1 to statement n, which you want to execute repeatedly, must be indented properly under the same code. So all of them should be aligned properly, otherwise it generates indentation errors. We saw this with the help of examples also in first unit itself. Okay, so look at this simple example for each pass in range of 4. So this range of 4 function generates the values from 0 to 3, that is 0, 1, 2, and 3. These values will be generated in every iteration. This each pass is a variable. Okay, variable refers to one value in that range in each iteration. So in first iteration, it takes 0 and prints it's alive, and is equal to, we are giving a space. That means the control will not go to the next line. So it prints it's alive and stays back here, okay, by taking a space. And it goes back again in the second iteration. Each pass is now referring to 1. That means it finds a value. Again for that 1, it displays this it's alive. And for 2 also, it displays it's alive. And for 3 also, okay, it displays it's alive. And finally, when it goes out of all the values of the range, then the loop stops. So here is the output. Okay, the loop iterated for 4 times. So that is how it works. It's a simple for loop. We saw examples already in first unit itself. And what is meant by count control loops, and how for loop can be used for this count control loop. So we all know that for loop can be used as a counter uh, through a range of values. It counts through a range of values, as we saw in the earlier example also. If you see this range of 4, it generates 0 to 3, and count points to that generated values one by one. And for every value in that range of values produced, this statement inside the for loop gets executed, right? So that is how it gets the output 0, 1, 2, 3. The same example, but this time just printing the values that is pointed by this count. Okay. Now, what is exactly this count control loop? Loops that count through a range of numbers are called as count control loops, just like we did here. Okay, that counts through a sequence of numbers, a range of numbers is called as count control loop. We can easily do this with the help of for loops without much code, without writing much code here. Just like here, suppose I want to find out the factorial of a given number. Let us initialize that factorial. Assume that product is equal to the factorial. Product is equals to 1. For count is equal to range of 4. And we know that this is going to be, so you should not write like this. Range of 1 comma 4 you should write. This is actually wrong. You should not write 4. You should write it as range of 1 comma 4. Okay, then only it works. Otherwise it will not work. So range of 1 comma 4, which means that the count iterates through these values generated. That means 1, 2, 3, 4. In every iteration, product is equal to product into count plus 1. Okay, if you take count plus 1, it is okay to take 4, right? So let me clear this, right? So range of 4 is okay because this will generate the values 0, 1, 2, and 3. Count takes one value from the range, and while multiplying we are adding plus 1 here. Therefore it is okay to take range of 4. If you write count here, you should not start at 0. It should be 1 comma 4. Okay, so product into 0 plus 1, that is going to be 1. In second iteration, 1 into 1. In third iteration, 2 into 1. And in fourth iteration, 3 into 2. Okay, and so on. It works like that. So in first iteration, let us understand this. 0 I am taking. 0 plus 1 is going to be 1. 1 into 1 is going to be 1. So the value of product is now 1. Initially, the product value is 1. After the first iteration also, the value is 1 again. Okay, and count equals to 1 in the second iteration. Okay, and product is equal to product into 1 plus 1, that is 2. So now already 1 is there in product. 1 into 2 is going to be 2. Now product contains 2. Okay, now in third iteration, count takes 2 and it goes inside and multiplies. Product is 2 already. Count plus 1, that is 2 plus 1, it's going to be 3. 2 into 3 is 6. Now product is 6. Okay, so product is 6 already. Now count takes 3. 6 into 3 plus 1, that is going to be 4. So 6 into 4 returns 24. So at the end of this for loop, product contains 24, which is equal to the factorial of given number. So if you print this value, print of product, okay, you will get 24 as output. Okay, just use a print statement here to print that value, right? So this is how for loops can be used as count controlled loops, which depends on a range function. It completely depends on range function to go through a count control values, a sequence of values. Okay, And also, because range function generates values, you can create it as a sequence or a list also. Okay, so to convert that range of values into a list, just typecast that range of 4 with this list function. Then it becomes a list of values, a sequence of values. Okay, and we saw how the range function works in earlier sessions also. You can use a maximum of 3 parameters, starting with the first parameter specifies the starting value, second parameter specifies the ending value, and the third parameter is the amount of increment that can be done. By default, the amount of increment is going to be +1. Okay, and the last number that you mentioned is excluded from the list. This we already saw several examples in our earlier sessions in first unit. Okay, so once you convert that range of values into a list, how do you traverse through that particular sequence? It is simple. Use a variable and then use this in operator followed by specify the sequence, that is a list of range of something, and now it points to the values. You can do whatever you wanted to do with that values. Okay, so that is how you can traverse through the contents of a data sequence. There is nothing new in this. It is same as using the range function, except that you converted that range values into a list. Okay, so I'm just moving quickly because all these topics are well known to you. We discussed about this in first unit itself while discussing that for loop. Okay, and this also we learned in first unit itself. How do you specify the steps in the range? Okay, so the third parameter, as I told you earlier, the third parameter specifies the steps. Okay, so this is the first value in the range, and the last but one value, that is last value, which excludes. This will be excluded, and this is the amount of increment. So if you say range of 1 comma 6 comma 1, it means that start at 1, take up to 5, separating the values by 1. Okay, similarly, if you say a range of 1 comma 6 comma 2, it means that start at 1, take up to 5, separated by 2. That means you will take 1, 3 and 5. This will be the output. Okay, you need to observe one thing, that it is generated as a list. Okay, and the third example is a range of 1 comma 6 comma 3, which specifies an increment 3. So start at 1 and last value must be 5. 1 separated by 3, 4, and if you add +3, it will be 7, which is not in the range. Okay, so this is how you can specify the step value that specifies the uh, space of interval to be taken between the values in the sequence. Okay, so again we are converting the range of values produced using this list function in all these examples. You can test all of these with your ideally or interactive shell. Okay, so we already practiced all these simple examples. We know how the range function works, right? Of course, we can count down using the range function also. We can start at the highest number and we can go back to the least numbers, right? So this particular range function, range of 10 comma 0 comma -1, starts at 10, moves back to 0, that is a value before this 0, that is 1. So stops at 1 by decrementing values by 1. Okay, this is incrementation again anyhow. Okay, so then what is this means? Range of 10 comma 0 comma -2. Yes, what will happen with this? The amount of increment is decrement is -2. So it starts at 10, separates the list of values by 2 now. That means it takes 10, then 8, then 6, then 4, then 2, then 0 will be excluded. Okay, so 0 will not be taken. So the range of values produced by this particular function is going to be 10, 8, 6, 4, 2. Okay, so that is how you can count backwards, starting at a highest number and going backwards. Okay, so it works exactly opposite direction compared to that moving forward, right? So you will first specify the upper bound range of the upper range, upper value in the range, and specify the second parameter as the lower value in the range. And this time the third parameter should be a negative value, otherwise it will not work. That means if you specify something like this, a range of 10 comma 0 comma, if you specify a positive number here, it does not mean anything. It will not produce any list. So it generates a empty list of values, empty sequence of values, right? Why? The reason is you specified it as a positive increment. If you start at 10, there is no way of moving towards 0 by adding 2. 10 plus 2 becomes 12. 12 plus 2 becomes 14, and it increases. So you will never reach this 0. The second parameter will be never reached. Therefore, it will not produce any range of values here. So you need to be very careful while counting downwards. The third parameter should be a negative value. Okay, so that is the point you need to remember. Okay, so another important thing that we will need to understand is formatting the output for the tables kind of data. Okay, so whenever you want to produce the proper output from a particular for loops generated as a table, you need to align them properly. So we know that the data that gets displayed on the screen can be either left justified or right justified through your Python program, and we already learned how to use that, how to mention that field with the help of point to percentile, point to f, and so on for the floating point numbers. But what if you want to align the integer numbers, either left justified or right justified, so that the look and feel of the corresponding output is better when it is read by the users. Okay, so whenever you have some data which must be displayed in the form of tabular format that contains headers, and the data needs to be either left justified or right justified in order to properly display the values, then you should specify this field with the help of the contents that we are going to see now. Okay, before we begin that, let us understand how the data looks uncomfortable when we do not specify a proper formatting options. So I'll give an example now. So this is a simple example. If you observe this, the output is the entire output is left justified by default. Okay, so everything is towards this, and if you look at this, it's not looking uh, effectively, or the readability of this particular output is not properly given. See, it is something like this. It's not properly aligned, right? So there might be a problem for the reader to understand this particular kind of outputs. So we need to be careful while producing an effective outputs, so that the readability of the corresponding output produced by our programs are effectively done. Okay, so now we'll see how to left justify and right justify the outputs that are produced by your Python programs. Uh, I will explain it now. Okay, so I told you that we can right justify the contents or left justify the contents. So please look at this particular example. It is saying percentile success percentile 4. So this particular control string specifies that you want to take the width as 6 spaces or 6 characters, or what you can say 6 spaces, and this yes specifies that it is going to be a string. Okay, and this is the string you want to display, second parameter. These two are separated by the percentile symbol. Okay, so percentile separates the control string and the text to be displayed. The positive value specifies that you need to write justify the contents, and the negative value specifies that you need to left justify the contents. Okay, so here it is saying percentile minus 6s. That means you want to left justify the content, and this is the content you want to print. Okay, so left justification and right justification are done with the help of the percentile operation here. Okay, so let me show you how it can be done. So I'm taking it to the ideally to see how it can be displayed. You can see it here. I specified 6 here, that is a positive value, which means that 6 characters space must be taken, 1, 2, 3, 4, 5, 6, and the text must be right justified, leaving the spaces on left side. Okay, so I hope you understood. And now if I specify minus 6 here, okay, you can see it. Left justification means text will be displayed from the leftmost of your screen, and because you mentioned the size of the corresponding string is 6 here, the total number of characters that gets displayed is 6 characters, and the remaining 2 characters along with the string contains 4 characters, right? The remaining 2 characters are left empty, that is towards right. So left justification moves the string towards left and leaves the spaces on right side. Right justification moves the string towards right and leaves the spaces, if any required, on left side. Okay, so this is how it works. Now have a look at a simple example how this is useful for us while displaying the content. Okay, so let us run this program here. So I'm just using a for loop from the range 7 to 11, means it will produce 7 to 10, right? Okay, now let us run this program. So if you observe the output, they are properly justified. Okay, so I mentioned minus 3D. That means I just want to left justify the exponent. Okay, this is the exponent value, which is in the range 7 to 10. So range of 7 to 11 will produce the values 7, 8, 9, and 10. In every iteration, this variable takes one value from this range, right? So it starts with 7. So whenever it displays exponent, because we specified it as percentile minus 3D, okay, so minus 3 means the number of spaces should be 3, 1, 2, and 3. Okay, and then this value 10 to the power of exponent, that is 10 to the power of 7, should be displayed with 12D. That means 12 spaces, and because it is a positive number, aligned towards right justification. Okay, so that is the reason why all these 7, 8, 9, 10 are left justified, and the result of that exponent 10 to the power of exponent are right justified here. Okay, so left justification and right justification, that is what we mentioned. Okay, now let us change these values. I'll swap that left justification and right justification now. Okay, so I'll give this as left justification and this as right justification. Okay, now let us run this program, how it gets displayed. Okay, so 3D percentile 3D is specifying that exponent must be right justified with 3 character space. So 1, 2, 3. So 7 gets displayed here, 8 gets displayed here, 9, 10 here. Okay, and because these numbers are left justified, they're occupying the immediate space. Okay, if you want to see the spaces between these numbers, then use more spaces over here. Okay, suppose I just want to use more spaces here, therefore I will take some 8d, and here it is minus 12. Okay, now let us run this program. Okay, the number of spaces, because you mentioned it as rightmost, the spaces are left towards this way. Okay, left spaces are all towards left. There are no spaces after 7, right? So that is the reason why, there is no space between these 7, 8, 9, 10 and the values produced. And because you mentioned it as minus 12 here, all the spaces are left over towards right. Left justification moves the spaces, takes the spaces on right side. Right justification takes the spaces on left side. That is the reason why there are no spaces taken over here. Okay, so what I want to say here is, while displaying the data in the form of a tabular view, you should be careful enough to align them towards left or right, and then producing a proper view for it. The corresponding output should be readable to the users. Okay, so in this, if you do the display of outputs in this way, it does not make any sense. Okay, so the best way of doing it is this way. So you need to be very careful which justification need to be taken for the columns, right? So this is the example that I wanted to show you. Now, let's move on to the next topic. So we'll consider, just want to conclude the topics with an example, an application, a real-time application. We would like to design a program for the real-time application where we are going to compute the compound interest. We call it as an investment report. Okay, we know that what is a compound interest. In compound interest, we'll calculate the interest every year, which compounds to the next year, right? So if you want to write a program to calculate that entire investment report by considering the uh, investment amount and the number of years and the rate of interest, by taking these 3 values, we would like to calculate the investment report for each year, and at the end of all the years mentioned, we should specify the ending balance and the total interest earned. Okay, so this is what I want to produce. This is the sample output screen that should be produced by your program that you are going to write. Okay, so what we are going to take is as the input is 3 input parameters are there. Investment amount you need to read from the user, and you should ask the number of years, and the rate of interest also you need to take. And then we will apply the compound interest formula to calculate the interest, and we'll add it to the principal amount so that ending balance is accumulated through the years. Okay, so let us start building this program. So the design part consists of 4 important steps. One is receive the user's inputs and initialize data. The second one is display the table header, because we want to display the report like this in the form of a table. This should be properly aligned. It contains 4 columns: year, starting balance, interest, and ending balance. 1, 2, 3, 4 columns must be properly given. These are the headers. You should display the headers. Then compute the results for every year and display them as a row in the table, just like this for first year. what is the starting balance, what is the interest calculated, and what is the ending balance. So like this, the ending balance of previous year comes to the starting balance of next year, and so on. You need to display everything in the table like this, and at the end of the table you should show the final ending balance like this, and total interest earned here. Total interest is simply calculated as ending balance minus starting balance. Okay, so this is what we are going to do, right? Now have a look at this program. So we'll start with reading the inputs. Three inputs we need to take. The starting balance. I'll ask the user as enter the investment amount, because whatever user enters, it is taken as string by this input function. So I will convert it into float. Okay. So now start balance is read. Then I will ask the user to enter the number of years. Okay. Input of number of years is again read as string. So I am converting it into int. And finally, I will read the rate of interest by asking the user enter the rate. Okay. I'm converting that rate of interest also into an integer. So after reading these three inputs, so we are ready to calculate and display the outputs. But before that, rate of interest is given as some number, 5, 10, so on like that. Actually, what he means is 5%, 10%, and so on. Therefore, you should calculate the actual decimal number that represents that rate of interest. Okay, so this rate of interest must be taken as some float. It is better to take it as float, not integer. Okay, so typecast it with float. So rate is equal to rate by 100. It gives the decimal number equivalent to the corresponding value given there. Okay, and then total interest is equal to 0.0. Initially, there is no interest incurred. And display the header for the table. There are 4 columns as I explained in the previous slide. The first column is year, second column is starting balance, third column is interest incurred, fourth column is ending balance. Okay, so according to the requirement of the actual values displayed here, you give the spacing options here. So here is maximum of 4 digits, so I'll take 4 spaces here. Starting balance, I am allowing up to 18 digits. Interest, I'm allowing up to 10 spaces, 10 digits, and ending balance, allowing up to 16 digits. So you can change these values based on your requirement. If you want to give more spaces, you can go with more bigger numbers here. Okay, so now these headers are displayed properly. Whatever you used here, better you use it the same numbers here. Okay, now I'm using a for loop to calculate the interest every year, and then accumulated interest that forms ending balance. Okay, so for year in range of 1 comma years plus 1, whatever number entered by the user, I will produce the values from 1 to years plus 1. For example, if user entered 5 years, I will produce the values 1, 2, 3, 4, and 5. Okay, because range produces the values 1 less than the uh, highest value you mentioned here. Okay, years plus 1 you need to specify, right? Okay, now for each year I'm going to calculate the interest using the formula starting balance into rate. So I'll calculate it. Then ending balance is equal to starting balance plus interest. It's a simple formula. Then display these values. We know the year, the first year in first iteration. Okay, and in second iteration it displays 2, in third iteration it displays 3, and so on. At this level, what is the starting balance that gets displayed over here? What is the interest incurred that gets displayed here? And what is the ending balance? We already calculated all these. Interest we calculated, starting balance we calculated. Okay, right. And then previous year's ending balance becomes the starting balance for the next year, right? So starting balance is equal to ending balance. I'm updating it, right? And also I'm calculating the total interest incurred, as total interest is equal to total interest plus interest incurred in this year. Okay, so I'll repeat these actions for the specified number of years by going through this range of values produced. Okay, and all the values are displayed in the table. Now the formatting options mentioned here, you need to understand this particular point. uh, these are the values we want to display, and this control string specifies the formatting options for displaying these values. Okay, this is the point you need to understand. The control string separated by a percentile symbol with the values, actual values to be displayed. Okay, generally we use the values directly with print statement, and this is extra now. We are specifying the formatting options here, followed by a percentile symbol. This should be a control string, so mention it in double quotes. Okay, and once the loop is completed, just display the ending balance. Okay, and finally the total interest end. Right. So this is a simple example. Uh, Now let us run this program, see how it works. So I'll copy the entire code. Open a new file because it contains number of lines of code. So I'll open it here. I'll say, and let us save this program on desktop. Okay, I'll give the name as one. So now the program is 1.py with all these lines copied over here. Now let us run this program and see. Let us, yes, it is asking the interest, that is investment amount. Okay, let us give it as 10,000, and the number of years I will mention it as 5 years, and the uh, interest rate I'll give it as 5. So you can see the output produced by the program. It is exactly same as the sample interface shown there. Okay, so it is showing the 4 columns, and the values are displayed with proper justification, a proper alignment. Okay, so it is exactly displayed just like you displayed it as a spreadsheet, right? So a proper formatting option applied on the outputs increases the readability of the corresponding output produced by your program, which need to be properly done while writing the Python programs. Okay, so this is how it works. Now let us finish our topic. So we have executed this, and here is a sample data sets for testing your program. Investment is 100 rupees, 1 year, rate 5. Okay, let us test it down with our program. After running this program, I just want to give that 100, 1, and 5 as input. 100, 1 year, and percentage of rate is 5. It displays only one row of values here. Starting balance is 100, interest rate is 5, interest incurred is 5. Therefore, the ending balance is 105. You can easily verify the answer. So the ending balance is 105. Total interest earned is 5. Okay. So like that, you can test all those data sets given over here for testing your program. Okay. Yeah, I'm leaving that part to you. All of you, please type this program and execute it properly. Okay. So this is a task given to you now. With this, I conclude this topic of definite iteration with for loop. Okay. So we saw an example application also. We run it, and we have given sample data sets to test the program. So this is all about how to format the data output that is getting produced by your Python program with the help of the formatting options. Okay, so you practice it with the different values mentioned here. Okay, and the data set given for testing also is given in the form of table. You test for all these data sets by running your program. Okay, so this is a case study that I wanted to discuss. Yeah, that's all for today. Uh, we discussed about the for loop, where we started with the conditional iteration, and then we have seen the count control loops, how the for loop can be used as count control loops, and then we focused more on how to produce the uh, data output in a more effective way, so that the readability of the output increases. Okay, so I wanted to discuss these topics today, and when we come back in the next class, we will discuss about the while loop again, and we will see the more concepts about while loop. We already discussed about the while loop in our first unit also, but we will focus more about while loops, and a few example application programs also will consider. Okay, so thank you all for your patient listening. See you in the next class. Thank you.